And finally, our Sunday revision. If I get time, guys, I'll put something last minute on tonight, maybe just a little 15-minute sort of overview of lots of things that maybe we haven't covered in the video, sort of a mop-up one, right? That'll give you everything then. We ended with this forming equations. I don't think I want to talk too much more about that. I said not to do that one. So if they're angle ones, right, add them up, right? So here, for example, let me just go back and do this one. So here, add up the angles, 5x, 3x, and 2x is 10x, right? Nasty numbers, minus 9, ugh, take away 2, so we're down to minus 11, and then add 1, so we're still on minus 10. Yuck, right? Not nice. Equals, well, what do those angles add up to? They add up to 180. That's the forming bit, right? And then take the number over. If it's minus, we'll add it on. We end up with 10x equals 190. So x equals 190 divided by 10, which is 19. This question says, show that the triangle below is not a right angle triangle. Well, in other words, show that none of the angles are 90, sorry. So here, 3x, there's x, 3x, 3 19s, 19, 30, 57, take away 2. So that one's 55. Well, that isn't the right angle. This one is 5 19s. 5 19s are 95. Take your time with that. Take away 9, which is 86. Close, but that's not a right angle. And finally, 2 lots of x, 2 lots of 19 is 38 plus 1. So that is 39 degrees. And again, that is not a right angle. So they could be angle ones, or they could be like perimeter ones, where they go, well, the perimeter is 60. So you've added up all of the things around the outside and put equals to 60. Right. Nth term. Let's just do a few of these. Right. First, second, and third term. Different answers for each one, right? So I want 3 answers here. So the first term, I'm going to swap that n there for a 1. Second term, I'll swap it for a 2. And the third term, I'll swap n for a 3. And then I work them out. I'm not going to remember squared means times itself. So 3 squared is 3 times 3. Then we're adding another 3, which is why we get 12. Nth term. What is the nth term? Right, nth term. So we need to know what it's going up in, which is 4s. But we write 4n. Okay, what's this going up in? This is going up in 4s as well. So we'll write 4n. And then come backwards a number. If we were coming down 4s, take away 4, take away 4, take away 4, take away 4. This number here would be 2, and that goes on the end. Whereas this number here would be 5, and that goes on the end. Okay? Yeah, that's all right as well. Right? They're very similar. What are the first 3 terms? Oh, all right. Something like this, though. Let me just write that in 5n plus 3, 1 there. The first 3 terms, you've got 1 squared, take away 2, 2 squared, take away 2, and 3 squared, and we're taking away 2 this time onto the, 1 squared, 2 squared, 3 squared. That's minus 1, because 1 squared is 1. That's 4, take away 2, that's 2. That's 9, take away 2, that's 7, right? Which is the first term with a value over 80? Well, that's not over 80. That's not over 80. That's not over 80. We're going to need something a bit bigger than that. So let's jump a little bit and try 5 squared, take away 2. Well, that's only 23. We're still nowhere near over 80. Let's jump to 9. 9 squared, take away 2. 9 is 8. 9 squared is 81. 80. Oh, I was going to say that's over 80, but when I take away 2, that comes down to 79. Right? So not even the 9th term is above 80, but the 10th term would be. Something similar here. 2 different sequences. There's the first one, there's the second one. Find 2 numbers that appear in both sequences, which are between 15 and 30. Okay, so the first sequence, 3 times 1, take away 4, minus 1. 3 times 2, take away 4, 2. 3 times 3, take away 4, 5. And keep going. You will start seeing a pattern because we're adding another 3 each time. It goes to 8, and we're going up in 3s, 11, 14, 17, 20, etc. Keep going. With the second one, 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. 4 squared plus 1 is 17. Right, there we are. That's between 15 and 30, and it's in both sequences. 5 squared plus 1 is 26. And I think we would get, if we kept going here, 26 would be in that one as well. That's sequences. Okay, my least favorite thing coming up here. Right. Put that number, because we've got a missing one, complete the table, because that we need to complete that. We need to put that number in here. So x squared, it's a lot of substitution, right? You can use brackets here, right? I don't know if it's easier. 3 squared minus 5, lots of 3, plus 2. If this comes up in paper 2, lush. If it comes up in paper 2, we'll put that in your calculator, right? Let's hope it does. It'd be stunning. We can just type that into your calculator, press equals, and put the answer there. So as long as you know how to write that, we're a way to go. However, 3 squared is 9. 5 3s are 15, which we're taking away. Add 2. Okay, 9 take away 15 is a bit like 15 take away 9, which is 6. But 9 take away 15 is minus 6. Add 2 is minus 4. And don't be put off if it's the same as another answer. Look, there's a bit of symmetry. Then we've got to draw it. So when x is minus 1, y is 8. Difficult with this paper. It'll be nicer bit on this. When x is 0, y is 2. When x is 1, y is minus 2. Then it goes to, if I remember rightly, to minus 4. Then the one we worked out stays at minus 4. Back up to minus 2 here. And when x is 5, we'll back up to 2. And I know that's not perfect. Smooth curve. Take your time through every point. Don't rush. And it's not. And this is not with a ruler. Smooth, like a U shape. Then I'm coming over here just to try and go through every point. I've missed one. Right? Don't worry if the curve. Oh, I've missed another. You're just doing your best to make it look curved, but going through every point. And then normally you get a part C. Sorry, this has got to be a draw a y line. So in this case, draw the line y is minus 3. It's about there. Someone, would you say minus 3? So y equals minus 3 with a ruler, please. Otherwise you'll get no marks here. And basically what they're asking you for then is these two numbers here. Now for me, I'm rough. We're going to be 1.1, 2, 3, maybe 1.4 and 3.6, something like that, right? But you be more accurate than that. That's just what you do. Okay. Yeah, I might come back to one at the end, particularly because what I want to just talk about really briefly with you is it's okay if the number's positive, but substituting in minus 1, not so much fun. Have I got time to do that now? Look, let's plod on and come back to it if we've got time, because one thing we haven't covered that I really want to talk about here is strict equations of lines. Okay? Right. What have we got? Right, I'm just going to do a brief thing. I don't want you to look at too many of these. Here's the deal. If they write for you, I'm going to get rid of this. Right? What is the gradient of the straight line? Now, what we're looking for is y equals something x plus, or maybe minus something. There are two numbers in there that I need, right? Now, we normally use the letter M here to represent this number. We use the letter C to represent that, but that doesn't matter. I'm looking for the number before x and the number at the end. The number before x is what we call the gradient. The number at the end is what we call the y-axis or the y-intercept. It's where it cuts through y, right? So here, the number before the x, even though you can't see it, we'd need to realize is 1. So if they said, what is the gradient of this line? The answer would be 1. If they said, what is the y-intercept? The answer would be 3. The gradient here, the number before x is 3. The y-intercept is minus 4. Here, the gradient is 4, the y-intercept is minus 3. Here, bit of a problem. It says 2y equals, whereas I needed to say y equals. So what we're going to have to do here is take the times 2 over here and divide by 2. So both these things we need to, all of these things here, we need to half. So the gradient here wouldn't be 4, it would be half of 4, which is 2. And the y-intercept would be half of 2, which is 1. And here, half of 5, the gradient would be 2.5. And actually here, so is the y-intercept because it's 5 as well. Now, how can I get those lines off a graph. Okay, this is the question I want you to follow. Okay, so what is the equation of the line? Now, okay, to get that number, what I'm calling the y-intercept, I need to look at where this line cuts through y. In this case, it's 6. The gradient is basically how far up or down does the line go for every one step across. So here, think of these as going up in ones, right? For one step across, this line has gone up to there. It's gone up 1, 2, 3. So the gradient is 3. You could do it anywhere on the line. For one step across, it's gone 3 up. So anywhere on that line, if you take a step across, you go up 3. Right? So our gradient for this line is 3x because it's going 3 up for every step across, and it cuts through the y-intercept at 6. Okay, there's lots on here that you just don't need. That's enough information. As long as you can go, I know the number before x is the gradient, I know the number at the end is the y-intercept, and if they draw a line and ask me for it, okay, you can pick out the numbers. Right. How long have I got now? I still have a couple of minutes. Apologies, I'm scanning back and forth here. Right. If they say, what's the lowest n could be? Right, what's the lowest n could be here? Right, well, if n is bigger than 7, it doesn't include m, so the least n is 8. I'm just making up ones now, right? If they say something like this, and they ask what integers, don't worry about the word integers. Integers, it just means whole numbers, so don't give any decimal answers like 0.5s or anything. 2 times n is between 13 and 19. Well, 2 times 3 is 6. That's not between 13 and 19. 2 times 4, 8. No. 2 times 5, no. 6, no. 2 6s are 12. It's too low. But 2 times 7 is 14. That's between 13 and 19. So n could be 7. 2 8s is 16. I'm still in the right zone. 16 is between 13 and 19. 2 9s, no? Yes, that's right. 2 9s are 18. We're still in the right area. But 2 10s are 20. That's too big. Okay? So it might say, here's an inequality. What integers, what numbers work? What numbers make n bigger than 7? What numbers make 2n be between 13 and 19? The other one is you might have to get yourself to this position by being given something like this, where you go, okay, it's a bit like Magic Bridge. I'll take the minus 11. We treat that like a bit of a bridge, right? Even though it's not an equals, we treat it like an equals. We add it on. 3x is bigger than 14. So x is bigger than 14 divided by 3. The difference in these is you don't tend to work these out. You just leave them like that, right? 3 goes into 14 like 4 and a bit. Don't know what the decimal, 4 and a bit times. So if x is, like here, if n was bigger than 7, the lowest is 8. Well, if x is bigger than 4 point something, then the lowest x can be the least x, which is what the question will ask for, is 5. Don't need this page. Sorry, don't need this page. Trial and improvement, paper 2. Okay, and then we're on to probability, which I'm going to cover later. So I'll actually go back. I will do a little mop-up, which includes probability, averages, and other bits and bobs later, okay? Have I got time to do one of these? Yeah, maybe just, okay? So with these, you can see inequality. Look for the word inequality. This is an inequality question. Inequalities are these things, right? That's the type of question. But here, we've got to form it, right? Rashid and Ivian. Okay, Rashid has n sheep. Ivian has 4 times as many. Rashid buys another 17 sheep. Ivian sells 8 of his. Ivian has more sheep than Rashid. Here's what you need to do. Whoever has the most, put them on the left-hand side. They have more than this one. Then this n can come over the magic bridge, and this minus 8 can go that way, a bit like we did earlier. Take that n away from there. Add the 8 onto there. So n is bigger than 25 over 3. If you work that out, 25 divided by 3 is like 8 and a bit. So the lowest n can be is 9, and we'll end that video there, and I'll do a mop-up video just to end later.